Hello friends, my name is Nishad Naik and today we are going to discuss application of projectile motion. So this is the figure of application. In this figure we have the mass which we throw at the velocity u making angle theta with horizontal, and it goes from O to A and A to B. So what we know is we know u, which is speed of that mass, we know theta, which is angle it makes with horizontal, we know total time t, and g's value is 9.8. Based on this given data, we will calculate the range and height of cliff. This is the height of cliff h1, and this is the whole range from this point to this r1 plus r2. So these two formulas we will derive in this session. So let's start. Let's move from first O to A, means from O to A, these 2 points. I will write here equations. V equal to u plus at. So I will write Vy, Uy and Ay. Now the final Vy means final velocity in the y direction. For that we resolve the vector, but this is final velocity in y direction. So finally it reaches at A, from O to A it reaches at A, and there is no velocity in the upward direction, so Vy must be 0. So 0 equal to Uy means initial velocity in the y direction, which is this y direction. This is initial velocity, so it will be u sin theta. U sin theta plus ayt. What is ay? Acceleration in y direction is minus g. Why minus? Because velocity is decreasing, and t we will take as t1. Vy is 0, uy is u sin theta, ay is minus g, and t we are taking t1 because we are moving from O to A, right? So it will be t1. So how to calculate this t1? We will shift this term here. We will get gt1 equal to u sin theta. So we will have t1 equal to u sin theta upon g. So this is time from O to A. Now let's write second equation, which is s equal to ut plus half at square, and I will write first y, and y. Now what is hy? Hy is the distance which is covered in the vertical direction. So from figure you can see that we are taking these 2 points O to A, so vertical distance is h2. So hy will be h2 equal to uy. What is uy? Uy means initial velocity in the y direction, which is u sin theta. This is initial velocity and this is y direction, so u sin theta. I will write here u sin theta into t is what? T1. So t1 plus half, and ay will be minus g, because we are moving in the vertical direction and speed is decreasing, into t1 square. So this is our value of h2. Then we will find the value of r2. No, sorry, not r2, r1. Means what is r1? We are moving from O to A, so horizontal distance is r1. So we will calculate r1. For that I will use this formula, s equal to ut plus half at square, but in this case we will write x, and x. Now we all know that ax is 0 because there is no force in x direction, so acceleration is 0. We will not write this term. Sx will be r1 because we are moving from O to A and this is horizontal distance, so r1 is sx. I will write r1 equal to ux. Ux means what? This is your ux, u cos theta. U cos theta into what is t? T1, because we are moving from O to A, so I will write T1. Now my question to you is, can you calculate T1, H2 and R1? And the answer is yes. Why? Because we know U, theta, T and G. So we know U, we know theta, we know G, so we can calculate T1. We know U, theta, G, T1, theta, so we will calculate H2, and also R1 is U cos theta T1. We know T1, then we know u, and we know theta, so we can calculate r1. But in all these cases we want to calculate first t1. So can we calculate t1? Because t1 is here, t1 is here, and t1 is also here. So can we calculate t1? The answer is yes. Why? Because from this formula there is u and theta and g. So from this formula we have got t1. We can put value of u, we can put value of theta, and g is 9.8, so we can get t1, and that is our t1 which we substitute it here in here. T1 we know, g we know, u sin theta, so h2 can be calculated. And similarly here we know u theta, and we also know t1, so r1 can be calculated. So for finding t1 we use this formula and substitute value of u theta and g here. So it is over 0 to a, we got all values t1, h2 and r1. Now let's consider second part of motion, which is from a to b. So I will rub this and I will write a to b. This is our second part, from a to b. Then again two formulas. First formula is v equal to u plus at. So v equal to u plus at. Again as usual I will write y and y. Now v means final velocity, means velocity at this point, because the finally mass is coming here, so we don't know that velocity. So we will write vy equal to, what is uy? Initial velocity in y direction. This is your figure from a to b. Okay, this is figure from a to b. At point a there is no there is no vertical motion, only horizontal motion, so we have only ux. So value of uy, no velocity, so 0. So 0 plus ay is g times t. I will write t2 because now we are in the different interval. Previously we took o to a, which is t1. Now a to b I will take t2. T2 means time from a to b. So we will get vy equal to g t2. This is the vy. Next we will use the formula of s, which is ut plus half at square, and I will solve it further. S equal to ut plus half at square. Now we will write t2 because it is second part of motion, and I will write sy, uy and ay. Sy means the distance covered vertically. The body is at point A, reaches to B, so vertical distance is h. So I will write h equal to uy means initial velocity in y direction. You can see we are taking this and this point, so in y direction there is no velocity. I will write 0, so this whole term will be 0. So eventually we will get half of ay, which is g, and into t2 square. Okay, I used equation s equal to ut plus half at square. I wrote t2 because it is second part of motion, and y and y because we are taking y direction. Sy means distance covered vertically. So distance covered vertically from a to b is this one, h. So we wrote h. This term is gone. G, ay is g because velocity is increasing, so ay must be positive, so g and t2 square. So we got h, we got vy. Now next is we will try to find out range. Now we will look at the figure, and we are in this interval a to b, so horizontal distance is what? r2. From this point, if you drop a perpendicular here, from this to this, initial to final, horizontal is r2. I will use this formula again of s equal to ut plus half at square, and I will write x and x. Now we know that x is 0 because no force in horizontal direction, so acceleration is 0. Sx we got r2. Total displacement from a to b in horizontal direction is r2. So I will write here r2 equal to ux, initial velocity in the x direction. What is initial velocity in the x direction? From a to b means from this to this point, only u cos theta is the vertical component of velocity, and it will remain constant. So ux will be u cos theta. There will be no y component because body is not moving upwards, so only u component, x component is there, and which is u cos theta. So as x component is there, ux will be u cos theta, and into t, what is t? T2, because we are in the second interval of motion. Now my question to you is, can you calculate vy, h and r2? Now from the given data we have the value of g, we can find out t2, then we have g, this t2, u we know, theta we know. So only we want to calculate t2 here. T2 is unknown. All other quantities we know the value of g is 9.8, which is 9.8 half. Then u and theta we know, only t2 we don't know. So how to calculate t2? Remember, in the first case we calculated the value of t1. So and we know the value of t is the total time taken from o to b. So I will write like this: t equal to t1 plus t2. Right? T equal to t1 plus t2. T means what? From o to b. O to b t total time. It will be divided into two parts. First o to a is t1, a to b is t2. We know t total time, we know t1, we derived it, so we can find easily t2 by substituting the value of t2 here, here, and in the last equation here. We know u, theta, g and this g, so we can calculate vy, h and r2. Okay, so we got r1, we got r2, we got r1, r2, this h. We want to calculate first the height of cliff. So how to calculate that? First let me rub all this. Okay, so we want to calculate the height of cliff. Height of cliff, from this figure you can see it is h1, right? This is the height of cliff, this is h1. So how can we calculate h1? H1 is what? H minus h2, right? H1 is h minus h2, because h is the total height, this is the total height, and this is h2. If you do h minus h2, you will get h1. So h1 is h minus h2, and we got h and we got h2. So subtracting both of them, we got h1, which is the height of cliff. So we calculated h1. Now next is we want to find r. R is what? From distance from here to here, means r1 plus r2. We have both r1 and r2. So total range I will write like this: r1 plus r2, right? We know r1, we know r2. If we add both of them, we will get r. Now the last question is, what is the velocity at point B? So I will write velocity equal to square root of vx square plus vy square, right? Vx square plus vy square. Then I will write equal to under root. What is vx? Final final velocity in the x direction. You can see from the figure, the initial velocity in the x direction is u cos theta, and it will remain same till here, because it is not changing due to because there is no force acting in this direction. So this velocity must be same, because acceleration is 0, so velocity is same. So when the particle comes from here to here, this component is same, which is u cos theta, and this is what? Velocity in the x direction. And this is so we will write like this. Okay, so this is the initial velocity in the x direction, but when it reaches from here to here, it will remain same. So final velocity in the x direction is also u cos theta. It will not change. So I will write final velocity in the x direction u cos theta, which is this final velocity in the x direction u cos theta, and I will write it square because it is square here, plus vy means final velocity in the y direction, and we calculated vy in the previous case from a to b. So we know vy, so vy square, right? So we know vy, taking it square, we know u and theta, so u cos theta square, we take its under root to get the value of v, which is velocity at b, final velocity at b. So in this lecture we calculated all the values: the final velocity, height of cliff, then range, and u, theta, and time t1, t2. So this is the very important application of projectile motion, and I hope you all enjoyed my video. In next lesson, in next session, I will discuss more about the concept of physics and with examples. So thank you very much. Goodbye.